Good morning. Myself Prabharan J, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is manufacturing test principle from Unit 4, which is design and testing, from subject name is VLSI system design. Okay, let us discuss. Manufacturing test is a crucial step in the semiconductor and digital systems design process. Once a chip or system has been fabricated, it must be verified to ensure that it free from defect, that means fault free circuit introduced during the manufacturing process. The purpose of testing is not only to guarantee functional correctness but also to assure quality, reliability, and yield. Yield is nothing but the percentage of good chip. And main thing is, first one is need for why we are going to use manufacturing test. Need for test. The semiconductor fabrication is highly complex and involving billion of transistor and multiple processing steps. Even with advanced manufacturing technique, defect such as open circuit, already we have discussed stuck open circuit and stuck short circuit, and parameter variation may occur during the manufacturing process. Testing ensures that only good devices are shipped to customers, improving trust and uh, also reducing the field failures. And main objective of manufacturing test is defect detection, which is identify chips with fault caused by fabrication errors. uh, and next is quality assurance, guarantee correct operation under specified conditions. Yield enhancement, provide feedback to manufacturing for defect reduction. Cost control, and reduce cost of test while maintaining high fault coverage. These all are the uh, main objectives of manufacturing test. And followed by, we will discuss the basic principle of manufacturing test. uh, Test generation, to generate the test pattern to excite possible fault models. Already we know fault model. What are the fault model? Stuck fault, which means stuck at zero fault, stuck at one fault. uh, what is meant by stuck at zero? Mm, the line permanently assigned to zero, that is called stuck at zero fault. Permanently assigned to one means we can call it as stuck at one fault. Uh, Next is bridging fault and the transition fault are used. Fault simulation is nothing but the evaluate test vectors by simulating fault and ensuring they are detectable of output. And already we have discussed the one of the principle is design for testability, DFT, which introduces special design features to make testing ensures uh, they are detectable and at output. Okay, what are the DFT test? Which is scan based test, built-in self-test, boundary scans test. All those comes under the DFT test. And another one is ATE, automatic test equipment. Apply test vectors to fabricated chip and compare output against the expected which response or output. Okay, and another one is test coverage, measure of how uh, uh, which means measure of how many modeled uh, fault can be detected, and high coverage, which is greater than or equal to 95 percentage, is targetable. Okay, these all are the some of the basic principle. Next one is uh, okay, these all are the next one is level of testing. Level of testing is nothing but the wafer testing and package testing and system testing. What is mean by wafer testing? Before packaging, to identifying fault dies, this is called wafer testing. And what is mean by package testing? After packaging, for final product quality. Okay, next one is system level testing. We have to validation at board or module level. These are the level of testing. Okay, let me do one small activity. That is, you have to find what is the value of the question mark position. Okay, find and comment me the answer, your answer. Okay, let me continue. Okay, test technique. Test technique, functional testing, structural testing, scan based testing, and built-in self test, boundary scan test. Okay, uh, let me see one by one. What is mean by functional testing? Verify complete design functionality, which is called functional testing. And structural testing focuses on model to fault, which means stuck cut fault, bridging fault, all those things. Next one is scan based test, uses scan chain for controllability and observability. Next is built-in self-test, chip test itself using on-chip pattern generation and signal analyzer. Next one is boundary scan test. For board level interconnect testing is called boundary scan test. Okay. Next is some of the challenges in manufacturing test. Let me discuss. First one is total test cost. Test time can be significant in overall chip cost. This is called test cost. And test data volume. Gigabyte of patterns for complex SOCs. This is called test data volume. Next one is fault coverage versus performance, which is striking balance between high quality test and minimal overhead. Next one is power and performance. Excessive switching during test may damage circuit. Okay. Okay, manufacturing test ensures defect-free, reliable product. Next is relies on fault model test pattern generation and simulation. It involves DFT technique to simplify test application and reduce cost, support yield improvement by providing feedback to fabrication. Okay, these all are the assessment for this video lecture. First question is list out the testing needs, and followed by any other examples of testing. And next is list out the basic principle of manufacturing test. What are the challenges of manufacturing test? These are the assessment question for this lecture video. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.